In Yellowstone National Park, a sleeping monster lies dormant under the earth. The Yellowstone supervolcano, one of the largest in the world, has remained mostly quiet for more than 70,000 years, the last time in which lava flowed. However, this giant has the potential for catastrophic eruptions. So what would happen if Yellowstone suddenly blew up tomorrow? Most volcanic eruptions are caused by molten or semi-molten rock called magma that accrues in chambers underneath the Earth's surface. Over time, these chambers slowly fill with magma and gas, which rises from the upper mantle and pushes on the lower crust. When a magma chamber comes under great pressure, it can forcefully fracture the surrounding rock, opening cracks and fissures in the ground. Through these cracks, volcanic material explodes onto the surface as lava or solid fragments called pyroclasts. This is what we experience as a volcanic eruption. If an eruption is large and violent enough, it may expel so much material that the magma chamber becomes unstable. The walls of the chamber may collapse inward, forming a large depression known as a caldera. This temporarily seals the underlying chamber, allowing magma and gas to accumulate once more. From the smallest smokestacks to the most devastating explosions, volcanic eruptions can vary significantly in magnitude and intensity. To measure these natural events, we use a numeric scale ranging from 1 to 8 called the Volcanic Explosivity Index or VEI. Each number on this scale represents a volume of ejected volcanic material, which increases by magnitudes of 10. A level 5 eruption may eject roughly 1 cubic kilometer of volcanic material, like the explosion of Mount Vesuvius, which overwhelmed the ancient city of Pompeii. Level 6 eruptions may eject 10 times more material, and level 7s may eject 100 times more. Many of these eruptions may be devastating, but they would not be considered super eruptions, a title reserved for only the highest level on the VEI. These colossal disasters are some of the rarest and most destructive natural events in Earth's history. Some super eruptions build under the surface for thousands of years until eventually exploding outward, ejecting more than 1,000 cubic kilometers of volcanic material and impacting the entire planet. The most recent super eruption occurred at New Zealand's Taupo volcano approximately 26,500 years ago. This gigantic eruption produced over 1,100 cubic kilometers of volcanic material and significantly transformed the surrounding landscape. The resulting caldera formed a large crater lake on the North Island, known today as Lake Taupo. Along with the Taupo volcano, the supervolcano at Yellowstone, also called the Yellowstone caldera, is one of the few active volcanoes capable of super eruptions. This is due, in large part, to its sprawling underground magma system, which covers most of Yellowstone National Park and has been active for the last 1 million years. During this period, Yellowstone experienced 3 climactic super eruptions, the last of which, at Lava Creek Tuff, created the caldera as we know it today. Lava Creek Tuff erupted about 630,000 years ago, leading some to wonder whether the Yellowstone caldera will explode again soon. It's hard to say exactly what would happen if this supervolcano finally blew. No one in the world today has ever witnessed a VEI-8 eruption, but such a climactic event wouldn't happen without warning. If a super eruption were to occur at Yellowstone, we may detect warning signs days, weeks, or even years in advance. Satellites may recognize deformations in the ground as the underlying magma chamber fills and bulges. Seismographs would capture increasingly powerful earthquakes that open cracks and fissures. In some areas, the ground may leak with steam or hot volcanic gas, foreshadowing an even greater disaster. If the pressure under the crust becomes too great, a series of climactic explosions may eject an extraordinary volume of volcanic material. A column of superheated pyroclast may erupt from the ground with enough velocity to reach the stratosphere. Large fragments of pyroclastic rock would rapidly cool in the open air, falling down to Earth as dangerous volcanic bombs. Meanwhile, a cloud of ash and volcanic gas may radiate outward, spreading over 1,500 kilometers and shrouding the area in darkness. Some volcanic material may be carried from the eruption site as far as the Pacific coast or the eastern seaboard, depending on the direction of the wind. Across the country, hot ash may fall from the sky, disrupting communications and compromising airborne planes, like toxic snow. Layers of volcanic material may also spread across roadways and buildings, damaging vehicles, power lines, and essential infrastructure. Thousands of acres of farmland may be decimated as crops wither and animals die due to respiratory illness. If a caldera-forming eruption actually happened at Yellowstone, large parts of the United States may become dangerous or uninhabitable. As volcanic material spreads across the country, devastating pyroclastic flows may spew from the blast site and race along the surface. These extremely hot currents of gas and volcanic matter may reach speeds over 100 kilometers per hour. Pyroclastic flows are among the most deadly and destructive volcanic hazards, capable of annihilating forests, farms, and even entire towns. Almost everything they touch will be scorched, burned, or flattened by volcanic matter as they reach temperatures exceeding 700 degrees Celsius. Some pyroclastic flows can travel dozens of kilometers from the eruption site and may be accompanied by thick and turbulent clouds of ash. Once these flows wreak havoc on the landscape, their materials may cool and solidify into complex formations of volcanic rock. When we think of volcanic eruptions, we imagine ash and lava, but we often forget the sheer volume of energy released by each climactic explosion. A super eruption at Yellowstone may release dozens of times more energy than the strongest nuclear weapons ever created. These devastating blasts may be some of the loudest sounds ever recorded, a record previously held by the 1883 eruption of Krakatoa. Each climactic explosion may be audible from thousands of kilometers away, as far as Mexico or the eastern seaboard, along with deafening noise. The explosions may create pressure waves that radiate from the blast site at the speed of sound. These shock waves may be strong enough to round the globe multiple times, causing worldwide fluctuations in atmospheric pressure and extreme weather patterns. It's hard to predict the immediate death toll of such a rare and powerful disaster. Over the years, scientists have made broad estimates in the realm of tens or hundreds of thousands of people dying on the first day of the eruption. Many may be killed by fast-moving pyroclastic flows or crushed by falling debris. Others may be suffocated by clouds of ash as they engulf cities and suburbs. Though the exact impact of this disaster may vary, a super eruption at Yellowstone would almost certainly yield one of the highest death tolls in the modern era. This catastrophe would not only claim many lives but also impact Earth's climate and ecosystem. When volcanoes erupt, they spew a range of gases into the atmosphere, like sulfur dioxide. When combined with water, sulfur dioxide creates an aerosol that reflects solar radiation into space. This may trigger a sudden cooling effect, decreasing temperatures and altering our global climate for years to come. In the past, climactic eruptions have caused similar cooling episodes, like the 1815 eruption of Mount Tambora in Indonesia. This level 7 eruption affected the global climate so dramatically that 1816 was nicknamed the year without summer. Though undoubtedly catastrophic, Mount Tambora ejected much less volcanic material than a true super eruption, which may propel the world into a prolonged period of global cooling, known as a volcanic winter. A few years of global cooling could have catastrophic consequences for our ecosystem. Entire food chains may collapse. Vulnerable species may become endangered or extinct. Even humanity may struggle as famine and disease plague our society, causing a significant decline in the global population. Luckily, the chances of such a catastrophe are exceedingly low. Some volcanologists say Yellowstone caldera will erupt soon, but soon on a geological scale could mean any time in the next 100,000 years. Right now, no signs have been detected of an impending super eruption outside the region's typical seismic activity. Even if signs were suddenly detected, they may be evidence not of a world-ending super eruption but a relatively common hydrothermal episode. Yellowstone National Park has one of the most extensive hydrothermal systems in the world and experiences large hydrothermal explosions every few hundred years. These sudden ejections of boiling water, mud, and rock fragments can form craters and claim lives, but they only threaten the surrounding region, not the country or the world at large. The possibility of a super eruption at Yellowstone is undoubtedly a terrifying prospect. It may be the largest volcanic event in recorded history, capable of impacting our planet on a global scale. However, a super eruption at Yellowstone, or anywhere else, is unlikely to occur in our lifetimes.